Okay, welcome back. This is part 2 of 8.1. We're going to apply those vectors in real life situations and problems. So let me give you some situations where that can be represented by a vector. For example, a hiker walks 25 paces west, right? So we have a number for the magnitude, right? How far? And we have a direction. So yeah, this can be a vector. And if I had to draw it, this would be it. To the left, because that's west, and at number 25 on top of it, because it's 25 long. How about this one? A boat travels 15 miles per hour. Wait, which direction? Right? So there is no direction here, but we do have a magnitude, right? A number, a value, but no direction. So this can't be a vector, right? Because it's just a number, and we can do things with that number, but we can't represent it with a vector because it's missing the direction. This one, a person's weight on a scale. Now, you would think no, because, well, a weight is a number, right? Your weight is a number, so it does have magnitude. But which direction? Well, it does have direction, because if you think about what weight is, it's actually the gravity pulling you, which direction? That's right, down, pulling you down. So it is a vector. You would draw an arrow down, and you would put the number, the weight, next to it to show the magnitude. So yeah, believe it or not, that is a vector. Let's talk about the components of a vector. Okay, components of a vector. Every vector can be expressed with two perpendicular vectors, right? What that means is, if you have a vector, you can transform it into a right triangle, like this, right? So here's my vector, and if I draw a vertical and a horizontal, you will get a right triangle. Now, if you remember from previous chapters, if we have a right triangle, we can do so many things with it, right? Finding sides, a squared, b squared, c squared, finding angles and sides with SOHCAHTOA. So you need to be aware that every vector can be turned to this, right? So those are the components of this vector. How about this vector that's going this direction? Well, here's the across, here's the up and down. Those are the components of that vector. Okay? So if you're given a vector, you can find the components, right? If you have even just the length of the vector and the angle. For example, if you're pushing a lawnmower, that would be down, right, sort of. 450 newtons, that's just a unit they use in physics. So the number is 456, and the angle's, the number is 450, and the angle is 56. So how would we draw that? Right? So there's, just draw an arrow, right? Just draw an arrow anywhere, but you have to draw it in the correct direction. So what do we know about lawnmowers? That you don't push them straight down or straight across, you push them that way, right? So I know the number is 450, and I draw the components, and I have a right triangle, right? So it's 450. Here's the angle, right, at 56 degrees. So now the components are this side and this side of the right triangle, right? Notice I cleverly call them y because it's going the y direction, and x because it's going the x direction. But this is enough information to find y and x, right? So we have angle. What do you want to find first? I found, right, this is what we want to find. We put bars around them because we're talking about vector. In the vector world, if you're looking for the length of a vector, you put those lines, right, those bars, okay? So I'm going to find x first. So that would be angle adjacent hypotenuse, AH, cosine, right? So cosine of the angle x over 450, do the math, and you get 251.6. Got it. So x is 251.6 newtons, right? Keep in mind the units that we're using, newtons. How about y? Well, that's opposite and hypotenuse, OH. Oh, so that'd be sine, right? Set it up, solve. Okay? So the components are the legs of the right triangle that's created. Yes, those are the components. Okay. Let's do a real life problem. Okay, so you're always going to start with drawing a diagram, right? And then you're going to use trig. Now, in the example that I just showed you, we used SOHCAHTOA because there were right triangles involved. Sometimes you're not going to get right triangles. You will get triangles, but not right triangles. Look at this example. A plane flies 310 knots, right? So that's a unit in airspeed, heading that direction. So I got a magnitude and a direction. The wind blows, so this is another vector, at this many knots in this direction. So find the speed and direction of the plane. Okay? So let me draw these two vectors, right? So if I was to start from scratch before I show you the whole thing, the plane, 50 degrees, right? So 50, that would be 90. So if we start here, that would be 90, 0, 90. So 50 would be somewhere here, right? That would be 50. Don't copy this. I'll show you a perfect picture, perfect drawing after this. So I got that one, right? And it's 310. So I'm going to put 310 there. And that's 50. Now the other one is 78, 125. Where's 125? Well, that's 90. That's 180. That's 90. So it's got to be here. Now notice that it's shorter than this, right? It has to be shorter because the number is smaller. 78. So right there, that's 125. This angle is 125, right? But what you need to know, because it says from, it's going this way, okay? So you can draw it messy like this. You're the one that's using it, right? You're the one that's using it, so not to worry. Now what? How do we do this? Well, he's going this way. The plane is going this way, and the wind, I'm going to move this to over here. So what is the resultant? You see the triangle that I made? Okay, so let's do it a little neater for the notes' sake. Let's do it a little neater. So there's my plane, 310, 50 degrees. Then I go to 125 degrees and draw a smaller vector going the other direction, because it's from 125, from the future, from the front, right? If the wind blows from a direction, it's coming towards you, right? That's another way to say it. So, and it's 78. Okay, now I want the resultant. What is it all this result to? So let me move this arrow, this vector up here, right? So I moved it from here to here, right? So 78, 78, right? So how did I know this was 75, right? Well, I know this is 75 because this is 50, this is 125, so this must be 75 to make 125 with these angles together. So I know this was 75. And then if you know your geometry, remember the AIA, the Z shape? If this is 75, then this is 75. Okay? So now I have a triangle that's not a right triangle. We're not going to use SOHCAHTOA, right? It's 75, not 90. It's not a right triangle. But we have those two laws, the law of sines and the law of cosines, that help us with non-right triangles. So which one do we use for this? Well, I redrew the triangle that we're talking about. right? So this is 310, this is 78, this is 75 degrees, and this angle we're going to need to find the angle that's over here. Okay, so let's worry about this angle first. So I can't use the sine rule because I don't have opposite angle side, right? Missing something, missing something, missing. So I can't use the sine. But I could use the cosine rule to find r, right? So remember the cosine rule? No? Okay, well, look it up. Remember it was a squared equals b squared plus c squared minus 2bc cosine a. Remember that? It's the cosine rule. Look it up. So I put this in bars, right? I put this in bars to show that I'm looking for the resultant, right? Squared, and I plug in the numbers. I'm looking for r, so I have to square root both sides and use the calculator, and you're going to get 299.4. So, I'm so sorry. The cosine rule, right? R squared is equal to all this. So R has to be equal to square root of all that, and it comes out to 299.4. So the plane speed, I found it, is 299.4 knots. That's 299.4, right? Now, I need to find the direction. Well, if this is 0, it's going this direction. So I need this angle. But I don't know that angle. Well, if we can find this angle, we can do the math, subtract, and find this angle. So let's find this angle. Well, now that we know r, we can use the sine rule because we have a pair, opposite side angle pair. So I use the sine rule. So this goes with this, and this goes with this. So sine theta over 78, sine 75 over r, which is 299.4. There it is. Do the cross multiplying and solve, and you get theta is 14.6. That's 14.6. But that's not how we measure direction. We measure direction starting at north and turning. So I need to know what that angle is. Right? But if you go over here, you remember that this is 50 degrees, right? 50, and this is 14.6. So why don't we just subtract the 14.6 to get this angle? Subtract 14.6 from 50. That's what I did here. 50 all the way in the bottom here. 50 minus 14.6, right? 50 minus 14.6 is this angle here, 35.4. So direction is 35.4 degrees. Okay? All right. Well, I'm done. Let me just leave you with a try problem and maybe a hint. So a man swims east at 35 feet per second. There's your magnitude, and there's your direction. The river current pushes south. There's your direction at 2 feet per second, and there's your magnitude. So find his speed and direction. Okay, so wouldn't this be, hey, I see a right triangle. Wouldn't this be the vectors that represent the situation? Okay, do your best. I'll give you the answer in class. All right, bye.